So now that we've talked at length about the CompletableFuture feature set, the basic methods, the factory methods, the completion stage methods, the exception handling methods, the arbitrarity methods, it's time to kind of put all the pieces together in a more comprehensive case study, which will be another turn of the crank on the ImageStreamGang case study that we looked at earlier. We'd taken a look at this earlier when we talked about parallel streams, and now we're going to take a look at it in the context of completable futures. So recall that several parallelism frameworks are applied in the ImageStreamGang example. Actually, there's like even more of them than we're going to cover right now. But what they all typically do is they get a list of URLs to download. They ignore any images that are already cached locally. Then they go ahead and download the non-cached images, so they'll be available on the device. They apply a list of filters to transform each of the images. So if you had 10 images to download and 3 filters, you'd end up with 30 transformed images as a consequence. Those filtered images are then stored in the local file system someplace on the device. And then finally, those images are displayed to the user through whatever means you use. We wrote a little Android application to do this. You can also do it other ways, but that's how we did it for one of the examples. Now, we talked about the parallel streams version earlier, and I want to kind of compare them and contrast them briefly so you can see them side by side. So the parallel streams version used parallel streams, hence the name. But the thing to note here is that all the operations that are done in the parallel streams version are all synchronous. So we check to see whether the images are cached synchronously. If they are not cached, we download them synchronously. Once we download them, we apply filters to them synchronously, and so on. What does that mean? It means that the caller thread blocks while the callee does its thing. In other words, the callee is borrowing the thread of control of the caller to do these two-way calls to get the request from the server and download it and then go to the next phase. So everything's done in a synchronous way, and we get parallelism here by using the managed blocker mechanism in the common fork join pool in conjunction with the parallel streams framework to run all those blocking calls in different threads. And that certainly works, and it's better than doing it in a single-threaded way. The CompletableFuture version, in contrast, uses behaviors that are all asynchronous. And so what we're going to do in this particular case is a more interesting set of steps. So let's talk about them one at a time. So the first thing we're going to do is we're going to check for image caches, for cached images, asynchronously. So all the images will be checked to see if they're in the cache asynchronously. We're then going to take the non-cached images and download them asynchronously. We're then going to go ahead and asynchronously apply a list of filters and store the filtered image in the file system after the download's complete. So as each download completes, we asynchronously apply those filters and store the results. And of course, we got to start the whole thing running. So that's what collect is used for here. So that'll trigger the stream processing to all run asynchronously. So all this stuff goes asynchronously once we call collect. And of course, that's going to return a single completable future while everything else is running in the background. And then the last thing we're going to do is log the results of the asynchronous computation after everything finishes running asynchronously. So pretty cool technique. Should come as no surprise. This is a bit like your third programming assignment, just a little different in various ways, but same basic kind of idea. And then ultimately, the images are displayed to the user. So why is this a win? Well, as usual, we're using the streams framework and functional programming in general to close the gap between the statement of the domain intent, which is download non-cached images, asynchronously process them and filter them asynchronously, store them asynchronously. That's the domain intent. And then the computations are the actual code that we wrote to do that domain intent, to realize that domain intent. And so it's actually quite close. The domain intent, which is the why, and the computations, which are the how, are very similar. And the use of completable futures is to make this more efficient. So rather than using the blocking mechanisms in parallel streams, which work but are not as scalable, we're going to use the asynchronous approaches instead, which are more scalable. So that's a quick overview of the ImageStreamGang case study. We will take a look at many different aspects of this over the course of the next few lessons.